As you know, we are learning Angular state management from scratch in this series. We are exploring each approach one by one, understanding how it works, what problem it solves, and when it actually makes sense. In the last video, we took our shared cart service and introduced RxJS. We used a behavior subject to hold the current cart and an observable to allow components to react whenever the cart changed. But the Angular has another way to build reactive state, that is signals. So in this video, we are going to take the exact same cart example and rebuild it using Angular signals. We will see how signals simplify reactive state and how they differ from RxJS approach we built in previous video. Remember, in our previous example, the cart state lived inside a service, so multiple components could share it. We are going to keep that architecture same. The only thing we are changing is how the state is stored and updated. Here we are importing signals from Angular, and instead of creating behavior subject, we are creating a signal. This signal holds our current cart. Initially, the cart is an empty array. So what is signal? You can think of signal as a value that Angular can track. We can read its current value, and when that value changes, Angular knows which part of application depend on it. But there is one important difference from a normal variable. With a normal variable, Angular doesn't automatically track every place where that value is being used. A signal is specifically designed to represent reactive state. Now let's expose this state to our components. I have kept the writable signals private and expose a read-only version called cart. This is useful because components should be able to read the cart, but they shouldn't directly replace the state. The service should control how the cart is updated. Now let's see, create a method to add an item to the cart. Here we are using the update method provided by signals. Angular gives us a current value of a signal, which is our current cart. We then return a new cart containing the existing items plus the new product. And that's it. No next, no observable, no subscription. We are simply updating the signal. Now let's see how a component uses this state. Our header component can inject the same cart service, and in the template, we can read the cart by calling the signal like a function. Notice this parenthesis. Cart means we are reading the current value of signal. If the cart contains two items, cart.length gives us a 2. Now comes the part that makes signal reactive. Imagine the product component adds another product, the signal changes, and because the header component is reading that signal, Angular knows that this part of UI depends on it. So when the signal changes, Angular updates the component automatically. We don't have to manually tell the component, hey, the card changed, update yourself. Angular tracks that relationship for us. And remember, our whole reason for moving the cart into a service was allow multiple components to share it. So let's say our cart also needs the cart count. For example, we created a cart component and we also need the same cart length here. Now both the header and cart components are reading the same signal. There is still only one cart state inside our service. If the cart changes, both components see the new value. Now let's compare this with what we built in previous video. With RxJS, we had something like this. And when the cart changed, we used next. Components then consume the observable, typically using the async pipe or a subscription. With signals, our state is much more direct. And in the template, we could use directly the cart.length. So the mental model becomes simple. Signal holds the state, components read the state. When the state changes, Angular knows what depends on it. But this doesn't mean Signal replace RxJS completely. They solve related problems, but they are not the same thing. Signals are primarily designed for reactive state and fine-grained UI updates. RxJS is a powerful library for working with asynchronous events and streams. Things like HTTP streams, user events, WebSocket, timer, complex asynchronous workflows can still be an excellent use case for RxJS. So the question is not Signal or RxJS, which one is better? The better question is what problem I am trying to solve. For simple or moderately complex shared state, signals can give us a very clean approach. We can keep the state in service, expose it as a read-only signal, update it through service methods, and let Angular automatically track the components that depend on it. And compared with our RxJS implementation, there is less code and less reactive plumbing to manage. But now we have seen something interesting. We started with a component owned card, then we moved it into a shared Angular service, then we made it reactive with RxJS, and now we have built the same state using signals. But what happens when your application becomes much larger? Imagine now we have authentication state, wish list, notification, filters, and many components updating and depending on all that state. At some point, simply having a service with signals might not be enough. So, what do you do when state management itself becomes complex? That's where we are going next. In the next video, we will take everything we have learned so far and finally look at NgRx. You will understand what problem NgRx is actually solving, why it is exists, and whether you really need it in your Angular application. If this series is helping you understand what state management instead of just memorizing tools, like the video and hit subscribe button. I will see you in the next part.